Now in part C, we are going to implement what we have learned in part A and B. We learned some rules about we analyze the system of equations. Now we are going to solve the system of equation by using this method. Of course, we'll start with 2 by 2. Normally you will say why we need this one for 2 by 2. We are just learning the method to apply it for 3 by 3. Okay, so 2 by 2 you can solve with your own way. There is no difference. So what our aim will be. So if we are given any system of equations 2 by 2, let's start and let it be dx plus ey equals to f. So first of all, we will only need the coefficients. So I will write a, b, and answer c, f, d, and e. Then what will our aim from part B? We learned that we can do some row operations. Our aim will be always to make these guys 0. So idea is if it's 0, then in the second row I will have only one variable. Then we can solve it easily. We can find what x and y is. So what we will do, we'll just multiply some number by a and subtract from the second row to make it 0. So you will have 3 cases. In your book, they usually give with 1. You don't have to convert to 1. So it's actually simple. If it's a, if you want to convert to 1, what will be? You just need to divide all numbers by a. So it will be 1, b by a, c by a. And if you want to, make all this one also 1. So it will be d by e, 1, f by e. So actually you don't have to do it. Okay, in the example I will show it. So here you have 3 cases. When you have number here, and when you made it 0, and here came any numbers, then you have always one solution. If you have 0, 0, and some number here in the second row, when you do row operations here, if you have this case, it's no solution because these 2 lines are parallel to each other. The only way it happens when you have, for example, like this case, inconsistency. If you remember, we talked about this one, x plus 2y equals to 6. When you subtract it, it will be 0, 0, and some number here. When you have this case, there are no solutions here because these 2 lines are parallel to each other. And infinite many solutions you have when there are just 2 lines are multiples of each other. There's only one. Okay, for example, x plus y equals to 5, and the second line, let it be 2x plus 2y equals to 10. For third case, to have infinite solutions, when 2 lines are just multiples of each other. It's actually the same line. So this type of system equation will have infinitely many solutions. So let's get started with the problem. For example, here, use row operations to solve. Again, we learn here how to practice it. First thing to do, we need to write the coefficients 1, minus 3, minus 8, 19, 4, and 5. And if you remember what we need to do, we have to make always, your aim is for 2 by 2, make these numbers 0. How you can make it? So if I multiply the first row by 4 and subtract from row 2 minus 4 times row 1 and replace it in row 2. Now after this one, what we need to do, row 2, let's write it row 2 here. It will be 4, 5, and 19. Then I need to sub row 1 times 4. It will be 4, minus 12, and minus 32. Right, then if we subtract them, what will be 0, 5 minus was 17, and this one will be 51. So let's rewrite it. Our new augmented matrix will be 1, minus 3, minus 8. So I need to write these numbers 0, 17, and 51. So your book says convert to 1 also this one. So what do you need to do? Just multiply second row by 1 by 17, but I'm telling you don't have to do it. From here, okay, we converted, we came to our aim. So I don't have these cases. As you can see, now I have my solution. As you can see, the second number corresponds to y. So what does it mean? It means that 17y equals to 51. So from here I can find y equals to 3. Now, first row that didn't change, so what does it mean? X minus 3y equals to minus 8, so I need to just put y equals to 3 here. X minus 3 times 3 equals to minus 8, and x will be 1. So here we found our solution, x equals to 1 and y equals to 3. So these one are our solution to the system of equations by row operations. Again, it looks easy. It's easy actually with 2 by 2. What if the main problem comes if we are given with the letters? Okay, so here we have letters, so we have to decide what kind of a and b will give us infinitely many solution or no solution. So let's discuss the solutions for a and b, all real numbers. So what do we need to do? Let's convert to the into the matrix. It will be 1, 3, 4, 2, a and b. Right, so here what do we need to do? We need to make this part 0. So what row 2 minus 2 times row 1, I just multiply by 2 and I will place in row 2. So what it will look like, row 2 is given as 2ab, and 2 multiplied by row 1, 2, 6 and 8. If we subtract them, it will be 0, a minus 6, b minus 8. So here, if we rewrite, our matrix will be 1, 3, and 4, and it will be 0, a minus 6, and b minus 8. Now from here, let's observe. If a is not equal to 6, if this guy, okay, based on these three ones, let's consider them. If a is not equal to 6, if a, we will consider the cases here, if a is not equal to 6, so it will have the unique solution, right? So if it was 6, it will be 0, 0, something like this, both of them, then there will be no solution or infinitely many solutions. So if a is not 6, then I will have unique solution. So what does it mean? Y times a minus 6 equals to b minus 8. So from here, y will be equal to whatever b and a is, b minus 8 and a minus 6. So if a is this one, then I have to just put in the first one. So the first equation is x plus 3y, and y we know it's b minus 8 divided by a minus 6 equals to 4. So from here I just need to resolve it. X will be equal to 4 minus 3b minus 24. Okay, let me just put in them in brackets. A minus 6, then you give common denominators and you simplify, you will find x. So it's the first case. What's the second case? If both of them equal to 0, if a and b, okay, if a equals to 6, the second case, if I open the space here, if a equals to 6 and b equals to 8, what will happen? So then I will have this case, right? So for this case, when a equals to and b equals to 8, I will have infinitely many solutions. So I will just consider, for example, y equals to t, if there are infinite many, or y equals to t, then from here, the first one, I know the line, it's the first case. Let me separate them. Second case, x plus 3y equals to 4, I know, so I call y equals to t, so x will be 4 minus 3t. Or vice versa, you can call xt and find y. So there are infinitely many solutions because they are same lines. And the last case, the third case, when a equals to 6, there is also this case, right? Where no solution. When a equals to 6 and b is different than 8. A equals to 6 and b is different, so we consider all the cases. So in this case, we won't have solution because they are parallel lines. So we will have this case, no solutions for this one. They are parallel here, infinitely many, and here we have unique solutions. So here, based on the letters, for any real numbers, we went with the case and we analyzed the problem. So here the main deal comes with this type of question. When they ask you to analyze it, we have to use these matrix to find correct result.